The next section, section 4.6, isosceles and equilateral triangles. We're going to first take a look at isosceles triangles. I probably should have written that section title the other way around, but first of all, an isosceles triangle. We know that an isosceles triangle has two congruent sides, and in this triangle we'll mark these two as the congruent ones. But let's talk about some of the properties and some of the terminology. The two congruent sides, we call those the legs. Those are the legs of the isosceles triangle. And then the side that's not congruent to the other two, we call the base. So the sides, we can be more specific, and we have two legs of an isosceles triangle and a base. The angles, in an isosceles triangle, these two angles are going to end up being congruent, and they're called the base angles. So here and here are the base angles, and then the angle at the top, we call it the vertex angle. That is this one right there. So we have some names for the sides and specific names for the angles in an isosceles triangle. So we'll look at a couple theorems. We already know these to be true. We won't spend a lot of time on them. But the first theorem, theorem 410, called the isosceles triangle theorem, just says is if two sides of a triangle are congruent, so if it's isosceles, then the two angles opposite those sides are congruent as well. So in other words, we have two congruent legs, and then we also end up with two congruent base angles. So theorem 410 says if we have congruent sides, then the angles opposite those sides, there's one, this angle is opposite the left side, or the left leg, then the two base angles are congruent. So it's kind of written this way. If two sides congruent, then the opposite angles are congruent. So that's theorem 410. So that leads to theorem 411, which is just the converse of that. And remember, in a converse, we just switch our hypothesis and our conclusion in this case. And so theorem 411, instead of saying if the sides are congruent, then the angles are, theorem 411 basically says if you have two congruent angles in a triangle, then the sides opposite those angles must be congruent as well. So we already knew these facts about isosceles triangles. Okay, let's look at some equilateral triangles now and look at some of the properties they have. So we'll get the best we can an equilateral triangle. Okay, and what makes a triangle equilateral? Well, it has three congruent sides. It has equal sides, lateral meaning sides. Well, if we use theorem 410 about isosceles triangles, that basically says if we have two sides of a triangle that are congruent, so let's go ahead and use this side as 1, this side is 2, this side is 3. If 1 is congruent to 2, then the angles opposite 1 and 2 must be congruent. And if 2 is congruent to 3, then the angles opposite 2, which we already have, and 3 must be congruent. So if we have an equilateral triangle, then what other kind of triangle do we also have? And looking at the angles, can we classify it? Yes, if it's an equilateral triangle, then it's also going to be equiangular. So all equilateral triangles are also equiangular triangles. And if a triangle is equiangular, that means all three angles are equal. And if all three angles add to 180 degrees, let's call one of them X, another one X, and then they'll all be X because they're all the same. And we'd say X plus X plus X would be 180 degrees. Or 3 X's would be 180 degrees. Or X would be 60 degrees. And you already may have known that intuitively, but if it's an equilateral triangle, it's also equiangular. And if it's equiangular, then all the angles are going to be 60 degrees. So there's one or a couple of the properties of equiangular equilateral triangles. So let's try an example. Let's say we're given an isosceles triangle where BA and BC are congruent legs. And we're also given another fact that the angle ABC is 60 degrees. We want to find the measure of angle BAC. So if I circle it, we are after this angle right here. Well, let's see what we know. We know that the three angles must add to 180 degrees. And since we also know that we have two congruent legs, then this angle, I'll call it 1, and this angle, I'll call it 2. They have to be equal. So if I don't know what they are, I'm going to say that the measure of angle 1 plus the measure of angle 2 plus 60 must add to 180. But if 1 and 2 are the same, then I'm just going to substitute. I have two angle 1s. Again, if angle 2 is the same thing as angle 1, then I really have two angle 1s plus 60 equals 180. 2 times the measure of angle 1 equals 120. And if we divide by 2, the measure of angle 1 equals 60 degrees. Now that's this angle, angle 1. It's 60. But since 1 and 2 are the same, and I was actually after what I labeled angle 2, angle BAC, it's also 60 degrees. Let's try one more example before we get done with the video. We're going to find the value of each variable in this problem. And notice we have one angle is labeled as 4x plus 20, another angle is labeled as 6y minus 2, and the third angle we know to be 52 degrees. Now, if we just simply try and add the three angles together and set it equal to 180, we won't be able to solve this problem because we'll have one equation with two different variables. So what we're going to try and do is use the fact that we know we have an isosceles triangle, which means the base angles, this one and this one, are equal. So you might think we can set 4x plus 20 equal to 6y minus 2 and solve, but that's not going to give us either of the values either because we still have one equation with the two variables. So let's find the way to do this. Well, we know if the two base angles are equal, we can find out what they're supposed to be. Together, all the three angles add up to 180. The vertex angle is 52. So if I do some subtraction, then I know the two angles in yellow are going to add to 128. But I also know that they're both equal too. So if I divide 128 by 2, I know that they're both supposed to be 64 degrees. Now I can go ahead and solve the problem. I can say that one of the base angles is 4x plus 20, and it equals 64. And the other base angle is 6y minus 2, and it equals 64. So simply by solving, we get 4x equals 44, or x to be 11. And over here, if I add 2 to both sides, I get 6y equals 66. And in this case, both x and y end up being 11. Now that's not true for every one of these problems you're going to do. It was true for this specific problem.